Consider the problem of implementing a MyMath class that has the following public methods. It has ABS that takes a double and returns the absolute value of this number, power that takes two parameters a and n and computes a to the n, and exp that computes e to the n, where e is the Euler's number 2.71 and n has to be greater than or equal to 0. Here is how we can implement it. Here is public class myMath. First of all, I declare the Euler's number E, that is 2.71828. I mark it with the final keyword because E is a constant that should never be changed. This is a constant and it should never be changed. And anytime you have such constants, you mark it with the final keyword. So final variables cannot be changed. That's why we are marking it final. And I also want to make it public so that outside users can access it. So I don't want outside users to declare the E variable again. It's already declared in here. I want them to directly use it. And here are the other methods. So ABS to compute the absolute value, power to compute the power of a to the n, and exp to compute e to the n. Here is the driver or test code that makes use of myMath class. So I have to first instantiate an object of type myMath. Then I can just simply call mymath1.abs to get the absolute value of this double number. And to access this constant e, I can just say mymath1.e. And here is another example where I am making a call to the power method in this class. So I instantiate another object and then make use of make a call to power. And here is another example where I'm making a call to exp. And first of all, I instantiate an object and then call the exp method within this object. I can hear you saying that why do we have to instantiate a new object to make a call to one of these methods? I already created the object at the beginning, so why don't I keep using it? You're absolutely right. In this example, I could have just created one object and used it to make calls to any of these methods and then access the constant. But this is just to illustrate that this part of the code maybe exists in one function, and this is in another part of your code, and this is in another part of your code. So what I'm trying to show you here is that anytime you need to make a call to one of these methods or access this constant, you need to instantiate an object. So this is just an example. Don't look at this code and criticize me for it. And here is what the code looks like. So we have the myMath class UML diagram, and I have to like I said, I instantiated three different objects, and each object contains the constant e, and they have these methods, public methods. And I just instantiated one object and then use that object reference variable to make a call to one of these methods. Is the actual implementation of this version of myMath. I have the public final double e, and then I have the member functions that implement each of the math functions that I am interested in: ABS, POW, and EXP. And here is the driver code that makes use of it. Again, I instantiate an object and then use that object reference pointer to access the constant and make a call to one of the member functions. And here is the second object, and here is the third object. Again, this is very inefficient because not only are we replicating the constant e in each object that we instantiate, but these methods are kind of not associated with the object itself. They're just some functions that they take some arguments and then manipulate them to produce a result. If you look at this version of myMath from the point of encapsulation, you realize that all the math methods in myMath do not really manipulate any data inside a myMath object. They simply take a set of parameters and work on these parameters to produce a result. So they have no relation whatsoever with the object they are bundled with. Ideally, we do not want them to be associated with an object of myMath, but with the class itself. The same applies to the Euler's constant e, which is right now replicated with each instance of the class, which is unnecessarily wasting space. ideally, you just want a single copy of this constant for everybody else to use. So we need a better solution. This solution that we have just looked at is no good. To accommodate such cases, all object-oriented programming languages have the concept of static or class member variables and methods. A static member variable belongs to the class, not to an instance or object of this class. Think of it as a global variable in C, C++, only encapsulated within a class. Similarly, a static method belongs to the class, not to a particular object or instance of the class. Think of it as a function in C, C++, only encapsulated within a class. Here is the new implementation of myMath class. As you can see, I mark the constant e with the static keyword so that it belongs to the class rather than to a particular instance of this class. I also marked every other method like abs, power, exp with the static keyword so that they belong to the class rather than to a particular instance or object of this class. So to refer to a static member of a class, we use the class name dot member name syntax. So we don't use the object reference, we use the name of the class. For example, in order to refer to e, we say mymath.e because we know that e now belongs to the class. Also, to make a call to any of these functions that are marked as static, like abs, power, exp, I have to say mymath.abs, mymath.pow, mymath.exp. Again, these are not member functions that belong to an object of this class anymore. They belong to the class itself. So here is the driver code that makes use of this new version of mymath class. So in order to access the e, constant e within this mymath class, I'm saying mymath.e. Again, I did not create any object of mymath at all, as you can see. I'm just saying mymath.e to refer to the constant e, which is public static final. And in order to make a call to any of these functions, I'm just saying mymath.abs, mymath.pow, mymath.exp. Here is the new version of mymath Java, public static final double E, public static double ABS. As you can see, every method now is marked with the static keyword because I want every method, every math method that's located in here to belong to mymath class rather than an instance of this class. It is also possible to have a static block, as you can see in here. So you say static and make it a code block by open curly brace, close curly brace. So the code that you put inside this static code block gets executed under two conditions. One, the first object of this class is created. So if you instantiate a class of mymath in any, for some reason, then this code block is executed. The second condition is when the first static method of this class is called. So if you make a call to abs, pow, or exp, which are the three static methods of this mymath class, then and only then this static code will first be executed because it's the idea in here is to kind of do some initializations within this mymath class before we go forward. And here is the driver code. So let me go step by step so that you see what's going on. So I'm going to start by accessing the Euler's number E printed out and look at the syntax. I'm saying mymath.e. I'm not instantiating any object at all, and I'm just printing it on the screen. So mymath.e, as you can see, is 2.718. Then I'm calling the abs function to get the absolute value of this number. So mymath.abs, and I should be getting a positive value. And you can see that before this call was made, that static code block was executed, and this output came from that static code block. Remember, I had this static code block that was just printing this message on the screen. So before the first time I made this call to ABS, that code was executed, and then the ABS function gets executed. So It will not get executed. This static code will not get executed afterwards, because it's going to get executed only one time. And now it's power and exp. So it turns out that these math functions that I implemented in my math.java, it's already implemented in the Java math class. So I could have just said math.py to get the pi, and math.e to get the Euler's constant. And also math class also has abs, power, exp, square root of the cosine, sine, lots of math library functions that are enclosed in math. I'll talk about it later on briefly, but this is how most of these math functions are implemented. They are all stored within the math class, and you don't have to they're all static, meaning that you don't have to instantiate an instance of math class to make use of those. Inside a static method, we can only access static member variables and method parameters. We cannot access any of the member variables if there are any, because when a static method is called, there is no object of that class. That is, this reference pointer does not exist. So the only things available within a static method are the static member variables of the class and the parameters of the method. Here's an example that tries to show you these concepts. I have a static member variable constant that belongs to the class, and I have a member variable that belongs to an object of this class. So I have normal methods, meaning methods that operate on the instance or an object of the full class. So get x to get x, set x to set x, and print1 to print x on the screen. A normal member method can access both the static variable of the class and the member variable of the class. But a static method, which is print2, can only access the static variable. It cannot access an instant variable. So if we were to print x in here, compiler is going to give us an error, because x belongs to a member or an object, belongs to an object of the full class. That's why a static method cannot access a member variable, because within a static method, there is no object, right? There is no this pointer, so you cannot access a member variable of an object, because there is no object in place. This is just a static member, like a global variable, a global function. Here's the driver code to test the foo class. I am creating two objects from the foo class, foo1 and foo2. In the first object, I'm setting x to 3. In the second one, I'm setting x to 7. Because getX, setX, and print1 belong to an instance of the foo class, I can make a call to these using the object reference. I can say foo1.setx, foo1.getx, foo1.print1. And also I can do it for using this second object reference foo2. I can say foo2.setx, foo2.getx, and foo2.print. But print2 function belongs to the class, not to an instance of the foo class. That's why when I have to make a call to print2, I have to say capital foo, the name of the class, dot print2. I cannot use any of these object references and make a call to print2. Here's a conceptual picture of what's going on in this example. I have a foo class that has one static constant and one static member function or method. Then I create two different objects of foo. One is foo1, the other one is foo2. In the first object, I set x to 3. In the second one, I set x to 7. So to summarize, constant and print2 are static members and belong to the class. So I need to refer to them as foo.constant and foo.print2. X, foo, getX, setX, print1 are instant member variables and methods and belong to each individual object. That's why I need to say, I need to use an object reference. I need to first instantiate an object and then say foo1.getX, foo2.getX, or foo1.print1, and foo2.print1. And here is the actual code. This is my foo class. Again, the first one is a static member variable. The second one is an instance variable. And these are instance methods, and this is the static method. Again, just to reiterate, within a static method, you can only access static member variables, but you cannot access a um, a member variable that belongs to an instance of this. And here is the test code. Let me go step by step. I'm going to create two objects, foo1 and foo2, and set the x value in foo1 to 3, and you can see that that's an instance member variable. Then I can call getX, print, and in the second one, I'm going to set the x value to 7, and then call getX, and print it. And to make a call to print2, which is a static member function in this class, I need to use the class name dot the function name or the method name, and we can see that. So we are in here, and again, to reiterate, we can, within a static method, we can only access static member variables. We cannot access instance member variables. And that's it. Here's a typical application where we could use a static member variable and a static method to solve the problem. Consider the problem of counting the number of objects created from a certain class for the entire duration of our application. We could solve this by declaring a static member variable, let's name it numObjects, that gets incremented every time an object of this class is created, obviously within the constructors of the class. We can then write a static member function, getObjectCount, that returns the value of numObjects to the outside world. Here is the actual implementation. This is numObjects initialized to 0. This is a static integer that belongs to the class. The class might have other member variables that belong to the instances or objects of this class, which in this case is x. So I have two constructors. And you can see that within the constructors, I'm just incrementing number of objects. So each time the new operator is used to create an object of the foo class, I'm incrementing number of objects. We've got getters and setters and add method to change the member variable x. But at the end, we have the static getObjectCount that returns num objects. Here is the actual code. So here is the foo class, and here is the app that makes use of it. In this example, I'm just in a loop. I'm creating 10 foo objects, and after creating a foo object, I'm calling foo.getObjectCount. So the first time, in the first iteration, the number of objects that I've created so far should be 1. In the second one, it should be 2, and so on and so forth. So let me just run this thing so that we can see what gets printed on the screen. So the loop iterates 10 times. So in the first iteration, the number of objects created so far is 1, then becomes 2, and after the 10th object is created, it says the number of objects created so far of the foo class is 10. And I'm also changing, I'm using the add method of the foo class to change the value of x by adding 10 to it. So it starts with 0. That's how I use the parameterized constructor to create the object. Then add 10 to the value. That's why the value of x for the first object becomes 10, then 11, then 12, and for the final object, it becomes 19. So when should we use a static method? If a method only uses its parameters and or the static class variables to perform its computation, then it should definitely be made a static method. If the method does not access any instance variable, then it does not belong to an instance of that class, obviously, but rather to the class itself. That's why you should always make such methods static methods. You should even check to see if the method should be part of this class, because maybe it should not be even part of this class and maybe located in some other namespace. Otherwise, if your method is using any of the member variables, non-static member variables of your class, then it should be a non-static member function. So as a last discussion, I'm going to take you back to the beginning of this class where I said the main function should have the prototype of public static. And I said we'll come back to this discussion of why the main function is static. So now I'm hoping that you understand why the main method in our app class is static. notice that when the Java virtual machine starts running our application, it does not have an app object yet. Actually, it does not have any object yet. But JVM needs a method to start the execution because this execution has to start somewhere. And that method must be independent of an object. Again, this is a chicken egg problem. You don't have any objects in the system yet, but the execution must start somewhere. So that somewhere, the main method must belong to a class, must be just enclosed in a namespace in a class, but it should not be part of an object because there are no objects in the system yet. We start executing in the main method that must be static, and the goal of the main method is then to create other objects and start kind of populating our application with other objects in the system and start running.